These are the notes for topic N37, rational exponents. Let's review the definition right quick. Okay, B for base, the base that has a rational or a fraction for an exponent can be rewritten like this or like this. Okay, just make sure you remember that when you look at your fraction, P over Q, okay, this is going to be your power, okay, and this is going to be your root. The power and the root. Alright, use the definition to simplify each of the following. 16 to the 3/2 power. Okay, that's going to be 2 for the root, so a square root to the 3rd power. Okay, notice that 4 cubed is 16, okay, and 4 times 4 times 4 is 64. Number 2, 27 to the negative 2/3 power. Alright, the denominator is a 3, so we're going to have the cube root and then a negative 2 for the power. Alright, 27 is 3 to the 3rd power. So the cube root of 27 is 3, so that's where this 3 comes from. So 3 to the negative 2 power, when you have a negative exponent, then you take the reciprocal. 1 over 3 squared equals 9. So this came from 1 over 3 to the 2nd power. That's where they got 1 over 9. Okay, number 3, 9 25ths to the 1/2 power. Since the root is 2, that's a square root. Square root of 9 is 3. Square root of 25 is 5. Alright, express in the simplest form using rational exponents. We're going to start off by looking at the base. Okay, this is your base. And then if you look at the root is the 6th root, and the power is 4. So the rational exponent is going to be 4 over 6. And then we're just going to apply the laws of exponents. Okay, since 27 can also be written as 3 cubed, okay, that's where this comes from. And we're going to apply this exponent to every number inside the parentheses. So 3 cubed to the 4/6 power, a to the negative 1 to the 4/6 power, and b squared to the 4/6 power. Okay? Alright, so the rules of exponents say whenever you have parentheses and an exponent outside, you're going to multiply these two numbers. Okay, notice that 3 times 4 over 6, okay, is going to equal to 12 over 6, which is equal to 2. That's where that 2 came from. Okay, and then negative 1 times 4 over 6 is equal to negative 4 over 6, which reduces to negative 2 over 3. That's where that comes from. Negative 2 over 3. Okay, and then the last one, 2 times 4 over 6 is equal to 8 over 6. When you reduce that, you get 4 over 3. Okay, and that's where that exponent comes from. So they applied the laws of exponents. In this case, you were to multiply exponents. Okay, 3 squared is 9. A to the negative 2/3 power. Since the exponent's negative, that's going to be written like this, 1 over a to the 2/3 power. That's why it's in the denominator here. Okay, and then 4 to the b to the 4/3 power. Okay, so that is the simplest form using all positive rational exponents. Okay, number 4. We're going to represent each one of these using a rational exponent, x to the 1/2, x to the 1/3, and x to the 1/6. Okay, rules of exponents tell us that we have to add the exponents when the bases are the same. Okay, so that's what this step is here. How did they get 6/6? Well, the common denominator is 6. So this is 3 out of 6. 1 out of 3 is equal to 2 out of 6. And 1 out of 6 is already in terms of 6. So 3 plus 2 plus 1 equals 6. And of course 6/6 is equal to 1. So x to the first power is what they did there. Okay, and then number 5, simplify 3x to the negative 1/3 power times x to the 1/3 minus 4x to the 4/3. Okay, all of that equals 3 minus 12x to the first power. So let's take a look at how they got that. First of all, only x has the negative power on it. So we're going to take the reciprocal of the x. So 3 over x to the 1/3 power. And this is distributive property. So we're going to multiply each one. X to the 1/3 power. I'm going to put that over 1. Minus 3 over x to the 1/3 power times 4x to the 4/3 power. I'll put that over 1. Let me write that a little better here. Okay, since this is multiplication, I'm going to check the diagonal. I can actually divide x to the 1/3 divided by x to the 1/3, and those both cancel, or you could say that they equal 1. Okay, so the first term reduces to 3, just like we saw what the answer is. Okay, on the second one over here, if we check the diagonal, okay, to reduce that, you think of it as 4x to the 4/3 power divided by x to the 1/3 power. Okay, laws of exponents say subtract the exponents. So 4/3 minus 1/3 is 3/3. Okay, so that's 4x to the first power. Okay, and that's where we get x to the first power. So where do we get the 12? Okay, that's going to be 3 times 4. Let me move some of this stuff out of here and go back and look at how we got that 12. Okay, in the original problem here, when we distributed 3x to the negative 1/3 times negative 4x to the 4/3, 3 times 4 is 12. Okay, so that's how we got the answer. Okay, on the last one, number 6, notice that we have the same base, okay, in this fraction. So the rules of exponents tell us that we're going to subtract exponents since it's division. Okay, the smaller one is to the 6th power. So I'm going to mark it off and put minus 6 on the bottom. Replace this with a 1. 1 over the square root of 3x to the 4th power. 10 minus 6 is 4. Okay, I have a square root and a power of 4, so I'm going to rewrite this as 1 over 3x to the 4 over 2 power. Okay, this is what we learned in this lesson 37 about rational exponents. And 4 divided by 2 is 2. So 1 over 3x squared, which is 1 over 9x squared. So that's your answer.